Good morning, everyone. My name is Anthony Aventino, and today I'm going to be talking about good manufacturing practices. I'm going to follow that with an example and a case study. This is for our manufacturing processes class in fall of 2021, and this is our first project. So before I talk about what good manufacturing practices are, I would like to define what manufacturing is. So, as we know, manufacturing has two different definitions, one being economically and the other one being technologically. When we're talking about manufacturing practices, we want to focus on the technological definition of manufacturing, which is the application of physical and chemical processes to alter geometry, properties, or appearance of a given material and turn it into something else, right? We're taking raw material and forming it into another thing. Um, this could also be used in assembly, but this is the definition we want to focus on today when talking about good manufacturing practices. So what is a manufacturing practice? Well, good manufacturing practices, also commonly referred to as GMPs, refers to systems devised in order to ensure consistent production and control manufacturing in accordance with predetermined quality standards. So what does that mean? Basically, a good manufacturing practice, again, a GMP, is basically just systems and processes set in order to ensure that we're having good products come out of the warehouse and that what's going on in the warehouse is moving on efficiently and also in a safe manner. A bad manufacturing practice would be the lack of having these standards or the lack of having these systems in place. So, like I said, GMP stands for Good Manufacturing Practice. But what are the qualities of a GMP? Well, GMPs usually exhibit consistent high quality in terms of the system itself, but also in the products. They're appropriate for their intended use, and they meet the requirements of marketing authorizations or clinical trial authorizations. I'll get more into this in a further slide, but there are systems and regulations set in place by, for example, the European Medicines Agency or the FDA that ensure companies to enlist some GMPs to make sure that production's flowing and production's going at an efficient rate, but also that the workers are being safe, and that customers are able to get a product that is safe and suitable to them. So some examples of GMPs. Um, some manufacturing practices that are commonly used. Repetitive manufacturing is what we're going to mainly talk about today as a GMP, but repetitive manufacturing is for repeated production, as per the name, that commits to a production rate, and also can include discrete manufacturing, which is similar to repetitive manufacturing but has some key differences. We're going to breeze over those today. But there's also job shop manufacturing, process manufacturing, continuous and batch production. Um, all these are different types of manufacturing and processes that business undergo. But today we're going to really focus on repetitive manufacturing for many reasons. One, I thought it was really interesting because it's kind of the biggest scale. Continuous production is high in repetitive manufacturing, and the big companies in the world, lots of food companies, beverage companies, oil companies, all use repetitive manufacturing to distribute goods and produce goods at an efficient and effective rate. So before I talk more on repetitive manufacturing, I want to talk about good GMP regulations. As I said a second ago, the FDA and the EMA are both clinical authoritarian organizations that enlist certain regulatory checks within every company for each of their manufacturing practices, no matter if it's repetitive manufacturing, job shop, production, batch production, all that stuff. It doesn't really matter on what it is, but the FDA and the EMA um, has all these regulatory checks to ensure this. Um, these checks may include like checks over the building, their equipment, personnel, everything down to the labels. I mean, they're really trying to make sure that the workers and the products are at top value in terms of when we're putting in place these GMPs, right? We want to make sure that the products are coming out to the highest of their ability, and we want to make sure the workers are working at the safest of their ability. So good manufacturing practices will obtain all of these regulatory checks and all these qualities, which help put the name good manufacturing practices behind them. So like I said, today our case study is going to be more focused on repetitive manufacturing. So as I said before, repetitive manufacturing is the ongoing production of the same product for an extended period, where it's typically assembled on a production line where tasks are committed by people or robots. This is what you commonly think of if you see like the car industry, right, where they have factories and this kind of build a bunch of cars and assembly line, or you think of what we'll get into is like the Hershey's chocolate, right? They can produce 70 million Hershey Kisses in a short amount of time. They can produce all these chocolate bars, Coca-Cola. They produce all these bottles of Coke, and it's the same system as you can see on the screen right here. These bottles are kind of going in a order line type of thing, right? Assembly line. So that's what we're really talking about with repetitive manufacturing is the ongoing production for the same product. Certain quantity of the product is targeted for production in each successive period. This situation most commonly arises when a business has steady stream of orders that do not vary over time. And some variation may include in repetitive manufacturing, but basically what this slide really states is that with repetitive manufacturing, since it's such a large scale, since it kind of goes with continuous production going 24/7, repetitive manufacturing is something that has little variation since you're kind of pre-assessing we're going to hit X amount of product, right? It's not job shot, it's not batch production. It's really co-aligns with continuous production at a 24/7 rate. So what companies like to do is a business says we got to hit X amount. They can predict how much chocolate bars or Coca-Cola bottles they're going to sell, right? They want to make sure, okay, we know how much we need to make, how fast can we make it, how fast can we get it out, let's make sure there's no flaws in our assembly line process, and so on and so forth. This is a good example of repetitive manufacturing. As I said before, repetitive manufacturing is very common in lots of big industries such as oil refineries. Food and beverage manufacturers are what we're talking about today for our case study. But as you can see on the rest of the screen, all of these different industries really specialize in repetitive manufacturing because repetitive manufacturing is really useful, having that system, having that assembly line in place for when you want to distribute high volume of product, right? So that's where repetitive manufacturing really shines, and it's used in lots of those big companies and big industries. So as I was hinting at before, Hershey's chocolate is an amazing example of repetitive manufacturing. Hershey's chocolate is really resembles a GMP in repetitive manufacturing for more than just they produce a high volume of product, but rather the stuff they put into their facilities and the regulations they impose on their workers and for their products really highlight what I showed in earlier slides, that what the FDA really tries to enforce on their industries, right? Hershey's chocolate is an amazing example of how to properly distribute and make a product at a high using repetitive manufacturing in a safe and really just a really good manner. It's a good manufacturing process. I set a link to the video here below. We won't be watching it right now, but this is how it's made, and it shows the full process of how Hershey's chocolate is made and how it's distributed across the United States, which is really cool if you get a chance to watch that. So like I said, as you can see in these images on the right, bottom one being Hershey Kisses, and the top one being chocolate bars. Hershey's chocolate uses repetitive manufacturing, and as you can see, the workers are wearing safety. This picture was taken during the pandemic on the top right, and you can see that they're following certain practices to ensure high production rate, and they're ensuring good product outcome. As you can see, he's inspecting every single bar, and these kind of back up those FDA regulations I showed you about GMPs in the beginning. So Hershey, as a good manufacturing practice, using repetitive manufacturing is perfect. It shows high investment rates, which are common in repetitive manufacturing. They invested $30 million in 2012, expanding its plant in Hershey, PA. The Hershey plant can produce 70 million Hershey Kisses a day due to high investment in repetitive manufacturing. As I said, 70 million of a single product is a lot to produce in a single day. Like I said, 24 hours, they're continuous production, but they would not be able to do this without GMPs in order, without having certain guidelines and a certain outline of how they use their repetitive manufacturing in their factories. And in the industry, I feel like if you watch the video, you can really see the efficiency that is present within these factories. So for conclusion, about the case study and repetitive manufacturing. So good manufacturing processes really inspired me for this project. The reason I chose this project was a few reasons mainly, but one, safety. I think safety is really important when we go in the day-to-day workplace. I think people don't realize that how much safety is really ignored in the workplace. The more I do facility tours or factory tours, the more I realize some companies are a lot better than others at maintaining safety, right? GMPs are really good for ensuring not as much safety regulations, but rather just keeping products in an efficient and safe manner, but ensuring that the customer can get their product as a full, complete, as it should be product, and not something that's has a defect or something that is unsellable, right? GMPs really ensure that every part of the manufacturing process is going to have a certain outcome, and make sure that the products that are reaching customers are in the best quality as possible. Efficiency. GMPs, good manufacturing practices, also highlight different processes. Like I said, repetitive manufacturing, you got batch production, you got all these different types of production that can go on for GMPs. They're all different types, but I think GMPs highlight individually how the pros versus the cons of each manufacturing process. GMPs are unique to each type of manufacturing process, and they highlight the specialty of each one. For example, repetitive manufacturing is good because it really shows the high rate of efficiency, but it also shows the high investment rate and the scale that it's on and how much product is being made, and with little variation. GMPs really highlight the efficiency of each type of manufacturing process. Production, like I said, GMPs can support high production rates, especially in repetitive manufacturing, as we saw with the Hershey's chocolate. Super interesting thing how companies can utilize GMPs to their own benefit and kind of pick and choose which practices they want to do. And then last one is quality. As I kind of said with safety, you want to make sure that yes, your workers are doing the top job and they're getting safety and they're making sure their products are coming out on top, but GMPs kind of force workers into producing a good quality product and kind of get a uniform system for good quality and good products to sell to customers, which is ultimately what keeps customers and what's ultimately the best for the business. These are my works cited. I would like to thank everyone for listening today. I appreciate your listening and me talking about good manufacturing practices, and especially talking about repetitive manufacturing as one of those practices. I hope you all have a great rest of your day. Thank you.
My name's Chloe Wilrich, and my project is Basic Glass and Ceramic Manufacturing and Processing. The motivation and history behind this project. So the motivation, I chose this topic because I've always been intrigued with glass making. I've always been interested in the glass blowing with the colors and shaping the glass. So I took this as an opportunity to learn more about the process. Ceramics date back to 2400 BC. They were made for holding water and food. They were created as art objects. They're used for tiles and bricks. So on the right is a picture of a ceramic bowl that dates back to that time period. Glass is thought to have been discovered in 8000 BC. It said the first man-made glass was accidentally created. The story is that a ship from Syria was docked and the merchants were preparing their meal on a beach. They didn't have any stones to prop up their pots, so they used lumps of nitrium from the ship. It fused with the sands from the heat of the sun, causing a stream of translucent liquid, now known as glass. The story may not be true, but Syria was one of the original centers for glass making. Glass was then used to make beads and make glassware to hold liquids and food. On the left is a picture of a glass bead. In 1800, the first porcelain, electrical, and incandescent bulbs were introduced, starting the era of technical ceramics. Soon after, insulators, spark plugs, and capacitors were produced. Okay, glass versus ceramics. The nature of glass is non-crystalline and amorphous. The composition of glass is mainly silicon dioxide. Glass is typically transparent unless tampered with. So, for example, the most known example I think would be in churches, the colored glass, the blues and reds and yellow colored glass. Glass is typically cheaper than ceramics to manufacture, so it's therefore cheaper for consumers. Excuse me. When heated, glass acts almost rubber-like and is very formable at high temperatures. So it's very easy to work with at high temperatures. Ceramics, moving on to ceramics, they can be crystalline or semi-crystalline. They're never non-crystalline, and they're inorganic materials. And the main component of ceramics is clay. Typically, ceramics are opaque, unlike glass, so light doesn't pass through them. When exposed to high temperatures, also unlike glass, ceramics harden and aren't easy to work with at high temperatures. So the picture on the bottom would be a picture of glass, which is see-through, you can see, and then on the right is the ceramic that is opaque. Moving on to methods of glass in manufacturing. So glass is considered an amorphous solid, which means it is in a state between two states of matter. It's typically known as a solid, but at the same time it can be qualified as a liquid owing to its somewhat fluid nature. Glass doesn't have any reactions with chemical compounds, making it non-thermal or electrical. The raw materials in glass is sand, soda, limestone, and clarifying agents. Jumping into the steps of manufacturing the glass. So step one would be batching of raw materials. The components of glass are weighed and mixed. Cullet is added to the mixture. Cullet is recycled glass, and by using this, it reduces the consumption of energy. Step two, melting of raw materials in the furnace. The batched raw materials pass from the mixing solution to a 5-chambered surface, and this is where the solution becomes molten. Step three, drawing the molten glass onto the tin bath. This molten solution is then floated onto a bath of molten tin. The glass is highly viscous and the tin is very fluid. When the glass contacts the surface, the two materials form a perfectly flat glass, which is then the shape of the final product. Step four, cooling of the molten glass. Now exiting the molten tin, the glass is cooled to then be placed in an annealing chamber. Glass is hard enough to be passed over rollers and is annealed, which modifies the internal stresses, enabling it to be cut and worked. Step 5, quality checks and cutting. After being completely cooled, quality checks are made and it is cut into sheets and automatically stacked and stored for transport. Okay, so continuing off of that, here is just a simpler description of all the steps. As I mentioned before, float glass, that's the process we just went over, known as flat glass, is made by floating molten glass onto a bed of molten tin. The glass is laid out onto a surface of the metal and produces a sheet of glass and cut to size. And this picture kind of describes that process and where that all takes place. So we'll go to this video.
Looking for the right manufacturer for your parts? And it spreads out to make an even layer that someone has to tidy up. The liquid glass cools and stiffens as it moves across the molten tin until it is stiff enough to roll into cooling ovens and then be cut by diamond blades that slide across the surface. The glass is inspected for tiny defects and bubbles by a unique automated scanning process that rejects anything not meeting specification. Large sheets of glass called jumbos, after being cut, are lifted and placed in stands ready for shipment. The stand of glass is moved from the production line to the shipping zone, where it's loaded into a dedicated vehicle that ensures the fragile glass reaches the customer in perfect shape.
Okay, that video basically just went over all the steps that I went through. It even shows the float glass process and everything that is used. Okay, going on to ceramics. So the method of ceramics manufacturing. Ceramics can be defined as inorganic and non-metallic solids, like I mentioned before. They're produced from unrefined clay and combinations of refined clay. Going into the steps. So step 1, milling and raw material procurement. The raw materials used for ceramics are typically found in mining sites. So everything used is mined. Step 2, sizing. So the materials are then sized to separate desired material from non-usable material. It's done using machines, one such as fine mine vibratory sifting machine. Step 3, batching, also known as blending. During this step, it calculates amounts, weight, and starts to blend the material. Step 4, mixing. The material is now mixed. Typically, the type of machinery used for this is a pug mill. Binders or plasticizers are added in this step as well. Step 5, forming. Materials like dry powders, paste, or slurries are molded for the desired product. Continuing, step 6, drying. The material that is now formed begins the drying process. The material does hold a lot of water. This water can cause imperfections, so convection drying is the solution to prevent any imperfections. Not saying that this prevents all imperfections, but this does help the process. So during this process of drying, heat is circulated around the ceramic piece, and this picture is a description of what's going on during that process. Step 7, glazing. This gives the product the finished look that is desired. The glaze consists of oxides and can be applied using spraying or dipping method. In step 8, firing, the product is passed through a controlled heat process, consolidating it into a dense body of uniform grain. All right, and we will play this video of manufacturing ceramics.
The ceramic mug. You use one every day. But how are they made? First, the raw material is fed into a grinder and pulverized into smaller, more manageable clay powder. The clay powder is combined with quartz, feldspar, and water in a mixer for 15 hours. The refining process continues as the clay slurry is fed into the molding tubes and cast into long clay logs, which are cut into specific portions. The portioned clay discs are placed into a single-use mold and formed into the shape of your mug. Once dried, the cup is removed from the mold by hand and is ready for the next step. Handle application. The mug handles have been created in a similar fashion to the body of the mug. Once they've dried and been released from their own molds, the handles are dipped in a mixture of clay and water called slip, which acts like a glue. It's time for some detail work. A technician carefully removes any excess clay or rough edges, rinses off any dust or debris, and gives the mug the perfect smooth finish. Now it's time for the mugs to obtain their color and trademark ceramic glaze. Some mugs are dipped into a single color glaze. The edges are padded and they're ready for the next step. Other mugs require a bit more flair, such as a specially painted rim or a different colored interior and exterior. All of the mugs are hand dipped and painted to ensure quality coating every time. The mugs are set aside for at least 12 hours in order for them to completely dry before moving on to the ovens. Now it's time to bake them, which will cause them to harden permanently. Rows and rows of mugs are placed onto a conveyor, which will carry them through the oven and out the other side. The standard oven temp is around 2,200 degrees Fahrenheit. Great news, your mugs are now finished and they look great. The shipping department wraps them in plastic, boxes them up, and ships them out to lucky customers all over the world. Some mugs will remain blank, and some will have a logo or text printed on them, transforming them into branding superstars. So the next time you're enjoying a cup of coffee, tea, or cocoa, take a minute to glance down and appreciate all the hard work and craftsmanship that went into your favorite mug.
Okay. Applications of glass and ceramics today. So glass, like I said, the float glass that would be used for buildings, so windows, facades, insulation reinforcement structures. Glass is also used for packaging, such as jars, bottles for drinks, cosmetics, plates, bowls. Ceramics, they're used and seen every day as well. So pottery, stoneware, chinaware, porcelain. They're also used still, bricks, tiles, and cement. Okay. And now concluding everything. So overall, the manufacturing process for glass and ceramics is very different, as you can see through all the steps and through the two videos. But both products have a huge and similar impact and role in our lives, like you saw in the applications of glass and ceramics. Ceramics, they both play roles in our homes, cars, and in the industry, despite the vast difference between the manufacturing processes. And they both are very essential and useful to us all. Okay, and here are just a couple of the references. And these are just websites that I got some of my information in the videos off of. All right, thank you. And that is all.
Hello everybody, my name is Isa Al-Kitan and today I will be speaking about paper and carton fabrication process. So my motivation for picking paper and carton manufacturing process. I wanted to know how paper and carton fabrication process evolved throughout the years, and how paper and carton also been discovered. And also I want to, my motivation was I wanted to know different types of uses for paper and carton. So historical facts about paper. The first paper making process was documented in China and during the Eastern Han period, which was in the 8th century. That was made from the bark of a mulberry tree. This bark fiber were broken and pounded into a sheet. Later, Chinese people discovered that adding hem rags and oddfish nets into the pulp would increase the quality of paper. Current paper fabrication processes require 7 steps in order to make. The first step is the pulping procedure. On this step, pulping is done in order to separate and clean fibers. This process is also aimed at removing lignin without losing fiber strength. By this, freeing the fiber and removing impurities that would cause discoloration and possible disintegration in the future. The second step is the refining procedure. This will be shortly followed after the pulping process. The refining process is really important because it improves certain sheet properties, such as density and strength related properties. At this process of refining paper, the fiber cell walls are delaminated, allowing them to absorb more water and also increase their flexibility. The third step is the dilution process. This is to form a thin fiber mixture. The fourth step, which is the formation of fibers on a thin screen. On this step, the fabric is woven into a screen. Various types of weaves are used to obtain maximum fabric life and to reduce wire marking. The fifth step is pressurization. On this step, this is critical to remove sheaves which are fiber bundle. On the sixth step is drying, which is to increase the strength of paper. And on the final step, which is the finishing procedure, chemicals are added on the paper, which also makes the paper quality much better. And this is a 3-minute video talking about the process of paper and how it is made. It was just like the 7 processes I just talked about. I just don't know how to show it on the PowerPoint. So if I just skip the first minute, and the next 2 minutes or 2 minutes and a half are the really useful parts of the video. So pros and cons of paper. Paper has the biggest advantage because it can be decomposed much more easily than compared to plastic products. But the cons of paper is that it has environmental pollution and hazard, such as various toxic chemicals like printing inks, bleaching agents, and hydrocarbons that are incorporated in the paper during the development process, which leaches into the food chain during the paper production process. Also, deforestation, because right now, currently, 40% of the global wood has been gone through paper. Carton processes. So, what is historical facts of carton? So, historical facts about carton. Carton was discovered in 1871. It took them 3 years to make a machine that can produce large quantities of carton after it was discovered. Carton became more famous to use when the Kellogg brothers used it to sell their famous cereal in. So in order to make a carton box, it has three main steps. The first step is corrugating the floats and gluing to a single liner. This process is done by 3 sheets of paper are unloaded simultaneously on the corrugator. The inner, the outer, and the middle, which is also called the medium. The medium is given a wave. This corrugation is obtained by pressing the sheets under heat through grooved metal rods. The operation gives the paper its flat shape in a single facer. Second step is gluing the outside liner, and the third step is cutting the board to desired shape. This is when the corrugated board comes out of the corrugator as a flat board sheet. Pros and cons of carton. So carton is affordable, has a good strength weight ratio, and is reusable, but carton can also deform under pressure and not weatherproof at all. A case study on paper manufacturing and how it has an impact on the world. Many people try to reuse, reduce, and recycle paper, but unfortunately it becomes overwhelming and sometimes end up dumped into a landfill. It is easy to forget that the production of paper has a huge impact on the world we live in. Deforestation has increased at an alarming rate. Paper manufacturing has used up to 40% of the global wood. The processes of making paper releases nitrogen dioxide, sulfur dioxide, and carbon dioxide into the air, contributing into the pollution such as acid rain and greenhouse gases. How do we reduce the impact of paper manufacturing? First, we can go digital with documents. By this, we can use Microsoft Word. Or use emails. This would make a huge difference, as shown as the picture above. Second is the most known, which is recycle the paper as much as possible. So in conclusion, I have talked about paper manufacturing processes, all different steps used in the paper manufacturing processes, the pros and cons of paper. I also talked about carton manufacturing processes, how it's different from the paper, but also similar in a way. The pros and cons of carton manufacturing, and a case study of paper and how the paper has impacted the world in the type of global effect. And this is my references in the next slide.
Hi, my name is Galina Lepahosky, and today for Manufacturing Processes ISEN 3723, I'll be going over fundamentals of fast-moving consumer goods, or FMCGs. So, introduction. What are FMCGs? What is fast-moving consumer goods? So, fast-moving consumer goods are products that will sell at a very quick rate while the producer of these goods maintains a relatively low cost to sell them. So these products that these companies produce for these FMCGs, they have a short shelf life because of these two factors. One, high consumer demand. They will be going off the shelves very quickly because the market and the consumers want to buy them. Additionally, these items will most likely be perishable. Therefore, they need to go off the shelf or they will not sell. In turn, they will not create a profit. So these products are bought very frequently, they are consumed very rapidly, they're priced low to appeal to the market, and they are sold in very large quantities in bulk to the retailer selling them as well as to the individuals buying them. So they also have a high turnover rate when they're on the shelf at a store because of these factors that they have a high consumer demand and they are perishable items. So here's some example companies that are FMGC companies. These are the top 10 European ones by sales. When you look at all of these, you will recognize their name. Nestle, that's a big name. Procter & Gamble, a very big name. Even looking ahead to Coca-Cola Company, very big name, very big and reputable brands that you will see in almost nearly any store you go into. Nestle does not limit themselves at just one thing. They encompass lots of aspects of these FMCGs, such as baby foods. You have the Gerber, different candies like Kit Kat, and I see Milky Bar, different types of cereals as well as bottled water that is all under the Nestle name, but branded as different types. So this just shows how diverse that one company can be. Procter & Gamble, they focus a lot on research and development, and they focus a lot on different types of care like home care, baby care, fabric care, feminine care. Looking forward to the Coca-Cola Company, lots of drinks that you will see in stores, very popular big names. L'Oreal Paris, also a very big name, focusing on a lot of beauty products. Kraft Heinz, a lot of different types of cheeses and condiments. These are very big names of items that go off the shelves quickly and are in high demand and are perishable. So what is the motivation for wanting to use these FMCGs? So firstly, there is the cumulative profit. So why would companies want to create this sort of idea where they have they make a lot of a product, but then they sell it for a low profit? So that's just because of cumulative profit. So the bottom line is that this cumulative profit has low profit margins, but that also means that a small percentage of the unit sales will represent profit. So over time, as they sell in high quantities, these will add up and end up actually forming a significant portion of a retailer's profit for an entire fiscal year. Additionally, cross-merchandising opportunities exist. So these cross-merchandising opportunities exist in order to strategically place, they work by strategically placing two products near each other in a store. So for example, if you have a remote control for an Xbox, next to the Xbox, you will find Duracell and Energizer batteries. That's because these are strategically placed next to each other because the batteries are FMCGs, and they are placed next to what you need them for. So when you go buy an Xbox, now you need to buy the batteries. So placing them near each other was a very strategic arrangement. Also brand appeal. So when we look back at these big names, Nestle, you have Kit Kat, Coca-Cola, Gerber, and under Procter & Gamble and under Kraft Heinz, you have Kool-Aid, Heinz, Kraft, Jell-O, all kind of big names. So this brand appeal creates a developed rapport with the consumers, and that's why they advertise heavily and establish a presence to gain the trust. Additionally, diversification. So diversification refers to a single company that spreads out the revenue of the company depending on the consumer demand. So when we look back at Nestle, they're not just focused on just one thing. They're focusing on baby food, on cereal, on water, on candies. Same with Kraft Heinz. They're focusing on cheese. They're focusing on different types of drinks, all kinds of things. That just shows how diverse one company can be. So looking forward towards methods, so manufacturing processes and procedures. So how are these FMCGs manufactured? Well, they're manufactured using this philosophy of lean manufacturing. So it really optimizes waste, focuses on methods engineering by optimizing processes, cutting your cost, reducing the time that it takes for something to get made. And how is it achieved? It's achieved by these four things. Machine alerts, that's number one. Machine alerts can include having a notification if like a machine goes down so that an operator is ready to fix it on hand. Additionally, machine changeover. So when there is a step-by-step process on how to switch over from one machine to another, or an operator from one machine to another. Utilizing the changeover process can help with the efficiency and the optimization of a processes. Quality assurance. So when you have an SOP, a standard operating procedure, you are able to ensure that the operators are following the best practices by being able to assure that what they're producing is up to the quality of the company. Additionally, safety checklists. These are very useful to avoid safety incidents that will cut down time for a product to be produced, as well as is simply just a safety hazard. So in order to produce more, you cannot have safety issues going on because that will affect your production. And this is just a little graphic showing lean manufacturing. The goal is to generate a smooth flow, identify the quality issues, eliminate waste when creating a product, do all the things at the right place, the right time, and also making the right quantity, because you don't want to make too much or not enough, or else your profits will be affected because you sell these at a low profit, and that creates a low profit margin. So the case study I have is FMGCs during the COVID-19 pandemic. The COVID-19 pandemic affected a lot of aspects of society, and that also includes this manufacturing and economic effects of these items being produced. So an introduction, at the beginning of the pandemic, there was a demand for consumer goods, and it was increased very heavily in these countries that were affected highly by the pandemic. So there was a big growth in goods for spending on household goods. For example, there was the toilet paper shortage. There was a new shortage every week on a product as lockdown went on. And the three factors that led to these increased purchases, it was for individuals wanting a reduced frequency of going to the grocery store because they wanted to avoid getting the coronavirus. Additionally, the stockpiling of food, the stockpiling of non-perishable goods, and the stockpiling of toilet paper really led to all these fast or high produced, low selling, fast creating products wanting to be stockpiled in individuals' houses. Additionally, e-commerce, the utilization of it helped increase it as individuals were buying things online, including their groceries, including their non-perishable items, including their household goods. All of these led to increased purchasing in FMCGs in the year of 2020 when the pandemic hit. So the consumption around the world also varied and also had its own effects. So in North America, there was a big surge in packaged and frozen foods, paper products such as toilet paper and hand towels, as well as household supplies such as cleaning. There was a limit on Kleenex tissues at one point. Additionally, with Clorox wipes, there was a limit on them, how many you could buy at a certain store. In Latin America, Brazil had an increased consumption of hygiene products as a result of they did not want to go out and go to the store, so they would just stockpile it all at once. Hand sanitizers in Brazil, the sale of them grew 623% in March of 2020. These are examples of FMCGs. Additionally, Colombians bought 30% more household cleaning products in 2020 than in the year 2019. And in Europe, the sale of over-the-counter healthcare products increased by 100% in Italy. Additionally, in other countries such as Germany and Russia, there were goods hoarded that were like pantry items such as like flour and rice. Disinfecting products were a huge deal as well as cereal and canned goods and masks ended up becoming the big hoarded item, especially at the beginning of the pandemic. In Asia, where the coronavirus originated, this hit very, very hard. Canned food purchases increased by 628% in South Korea in 1 week. There was a lot of issues with supply chain, and the issues with supply chain continue to affect the supply chain as a whole going forward as we are continuing on through the pandemic. So the effects of the pandemic on this retail, the consumers had to have more consumption in their home. They had to have more concern for their health and well-being, which meant in turn there would be more hygiene and prevention awareness. So they were buying more masks, more hand sanitizers, more soap, more Clorox wipes than ever before. Shopping. So people, when they would go shop, they wanted to shop at one place. So that effect of having the strategic placement in a store and the cross marketing and the cross utilization of products, such as the battery example, that was a big effect of shoppers during the pandemic, as well as regulation on how much if you needed masks at a certain restaurant or at a certain store, individuals would have to buy it and make sure that they had it on hand. So that became a very highly sought item. Additionally, the priorities of the retailers were shifting to focus more on e-commerce as online loyalty was gaining, and maintaining that sales and in terms of the revenue during even at the start of the pandemic, e-commerce really shot up, making sure that it's not just a trend where it shoots up real quick and it immediately falls back down. Make sure that it is a sustainable environment for the FMCGs. Additionally, redesigning stores. This was also a big thing for the longevity of FMCGs after the coronavirus pandemic first hit, as well as the innovate to compensate. So when food services had to kind of end their in-person dining, FMCGs were still being bought to feed people, and they just had to do takeout. So this was how they innovated in that manner. So looking forward in the post-pandemic / lockdown, FMCG, my bad, they will have to look at direct-to-consumer D2C operations to expand social commerce. So that includes offline to online marketing, social commerce, and subscription services. So these challenges are going to include: how do we extend the shelf life of these goods that are going to perish on the shelf? How do we reduce the impact? Creating more and selling for less means cheap packaging that harms the environment. So how do we reduce that impact? Also, how do we keep the low prices while maintaining competition with these companies? So there's multiple companies bringing out the same products. So how do we keep those low prices? And that's by developing a rapport. So in conclusion, fast-moving consumer goods can generate adequate profit margins for companies if they are marketed correctly. Looking at the manufacturing process that is used, it's lean manufacturing, and that is necessary for the sustainability of these companies. Also, the pandemic will continue to affect the market of how these goods are sold. And the production of these products will continue to evolve with the need of consumers in the market. That depends on the economy. That depends on what's going on in the world. Who would have thought the pandemic would happen? And in turn, these companies such as Procter & Gamble and these companies that own Kleenex and Clorox would end up creating all of these more of these products because of the demand for them. And these are my references for my presentation. And thank you very much for joining to hear more about the FMCGs.
Hello, I'm Hunter Gladden, and today me and Richard Graham are going to be talking to you about painting, coating, and surface enhancement processes. We are Group 11. First of all, we found it was important to discuss as to why we chose this topic and why we found it was important to tackle. First of all, there's so many applications and many different processes that you need to understand how each material is applied different, or each application is very, very different and unique to one another. So it's important to understand each of them individually. Otherwise, they don't always apply to one another. Secondly, it's important to find the best types of testing and treatments for each material in itself, again, because of the different properties and possible chemical makeups and physical differences in each of the properties of the material. And thirdly, it's important to understand the quality analysis tools when you're applying it to the relation of the manufacturing processes. So it's important to know your order of operations when it comes to surface treatment. So quality analysis will help kind of cut out that in between, where if you don't know if you should apply this treatment yet, for a certain quality analysis tool, if you check, okay, is this deburred enough? No, yes. Okay, is it clean enough? Yes, no. We will talk about all that later. It's important to check it prior and then post treatment. And then finally, it's important to understand what types of surface treatments to use to get certain desired outcomes. So each material has all these different treatments you could do to it, but then you can also change how you do each treatment to get certain outcomes out of it. So we'll talk about how all of these will come together momentarily. But before that, it's important to kind of look back to understand where we're going. So some of the first applications start with painting. Painting is a type of compound that's been around for over 100,000 years, and it was first used to mark cave directions or burial places in their intricate systems that they had down there underground. Or they even did it for war paint, stuff like that, or just decoration. And then next is coating. Coating was most commonly used in the automotive field, and Even back in the day in the 1800s, it was used to protect horse-drawn carriages exteriors from rocks flying up or paint chipping or anything of that nature. And then finally, surface enhancement. Ancient Egyptians used this to sand surfaces, to smooth them, to find lower friction when you're moving certain objects. That's how they're able to build a pyramid, stuff like that. And then they even started to push into the weaponry, the blacksmithing, and the hardening of steel and stuff like that. So blacksmithing is a big kind of surface enhancement that they kind of moved in that direction. We don't really talk about that as much, but we thought it was important to mention. All right, first start breaking it down into its parts. Painting. Painting has four main components that make it up. Number one is the pigment, provides the color, does the hiding, and controls the gloss of the surface. The resin is the binder of the pigment particles together and basically provides adhesion to whatever surface you're putting it on. And the solvent next is the carrier of the pigments in the resin. Basically, the solvent can be like organic, like a mineral terp or a water, just something to kind of push the material where it needs to be. And then additives. It's basically when you go to Home Depot and you see your favorite Behr paint, and there's so many different applications you can put on your deck, you can anti-scruff, sealing. It's just like it has different applications to its specific purpose so that it'll work best for that best result. And there's so many different additives that you can put in there to make it the exact outcome that you're desiring. Finally, paint can be used in different colors to achieve aesthetic desire, heat reflection and absorption, and organizational or systematic reasoning applications. So basically, when you're in a warehouse and just want to know what part of the system your part is in, or what direction your manufacturing is moving, depending on a color-coded part, it's an easy way to do that. Next, coating. Coating is traditional wax or sealant. Most traditional or well-known applications are automotive wax. Car wax comes in spray, paste, or liquid variants with formulas suited for variant paint types, so you don't destroy your type of car's paint or whatever you're looking into doing. Car wax tends to be sticky with a low melting point. It tends to attract dust to the paint surface and will need reapplication many times if there's any car guys out there. The car wax formula usually consists of a blend of carbon wax mixed with other waxes such as beeswax, natural oils, and sometimes also includes petroleum distillates. Many fewer formulations also contain special polymers and resins that are used as both car wax hardener and shine enhancer. So just as the paint has specific applications, the coating does as well. So paint sealant, on the other hand, is manufactured from synthetic waxes, and it's not as natural or as earthy as the others are. They're designed to better protect the surface rather than just make it look nicer. They also adhere to the paint better, and they don't have to wax it as often. And then the next one is surface enhancement. This one has many applications as well, and it mostly involves the altering of the molecular surfaces and conditions of the product. And this is used in so many industries and can take place in separate manufacturing processes. And this is the key process in improving the functionality and performance and the longevity of whatever part you have. So it's important to recognize that most parts that you see on any automobile or any rocket or anything that you see in aerospace or anything like that definitely has some type of surface enhancement to protect it from whatever harsh conditions, or in any part that seems to be in any high stress or high strain situations. There has definitely been surface enhancement to do there. And it's a lot of topic to really cover, so I'm going to pass it along to Richard here.
All right. Thank you, Hunter. I just wanted to talk about some surface enhancement processes and the methodology that goes into them. Right off the bat, we got sandblasting. This is a pretty simple procedure. It's the act of smoothing or shaping a surface by forcing particles at high speeds. Typically, it's sand. It could also be grit. This is comparable to using sandpaper on objects. There can also be various types of materials that can be used. An example of this would be wet abrasive blasting and bead blasting, which is the use of glass particles. Lastly, sandblasting is usually a single man operation, and it is typically an easy procedure. Next up, we have deburring. This is the act of removing small imperfection from machine products, also called burrs. To me, burrs have a tendency to look a lot like hangnails, but on metals. The burring machines can come in many different sizes and shapes since they have different uses at different companies. This process can also be performed manually or automatically. The most common burr leaving machine processes would be milling, drilling, engraving, and turning. Next up, we have polishing. This is another example of a fairly simple process that can be done by a single operator or it can be automated. Polishing is used to enhance the appearance of an item. It can make an object shiny, have a different surface finish. It also helps create a defect-free surface in metals. Polishing also helps removing oxidation from metal objects. Polishing can honestly go a long way when it comes to the longevity of a product. So next up, we have pickling. This is a big tank with typically metals that get placed into it with an overhead crane. And it is a solution of nitric and hydrofluoric acid. This pickling sludge is the waste product from a pickling operation. This sludge is classified by the EPA as a hazardous liquid. So what needs to happen is it needs to be neutralized by lime and disposed in landfills. This process can be applied when a colored outside layer can be seen on an object. The overall scope of this process is it's designed to remove various substances. Some examples of that would be removal of grease, oil, oxidation, and embedded particles that may have got in, unfortunately, through handling. Ultimately, pickling restores a natural corrosion resistance in metals. Next up, we have degreasing. Lubricants and grease are often used while working with machines. Degreasing machines remove any grease from various metals, glass, or plastic items. Degreasing helps make an object free of any contamination resulting from production. The degreasing machines themselves use a solvent and a washing system very similar to that of a washer to remove these contaminants. Processes can be used to prepare a part for further operations such as painting. This process is an easier way to clean products as compared to pickling. Another example of surface enhancement procedures would be the eddy current. This is a non-destructive electromagnetic test. Eddy currents are an induced current produced when a conductor is placed in a changing magnetic field. This eddy current is able to accurately detect defects on surfaces. The eddy current can be automated for large batches of the same product. And the eddy current is especially useful for inspecting tubes or pipes. Next up, we have an ultrasonic tester. The most commonly used materials used in this machine would be just metals and alloys. This equipment can either be portable or stationary. The portable ones are typically used with contractors that can go in and inspect water pipes to make sure they're running well so no emergencies happen or anything hazardous. An ultrasound transducer is connected to a diagnostic machine where it then passes over material. A probe or multiple probes then sends ultrasonic waves that travel through an object or material. Two indicators are produced, an initial pulse and a back wall echo. A defect will create a third indication and reduce the amplitude of the echo. When this happens, you can obviously point out the defect in a material, as well as you can come close to the size of it and the location of it, all from this one machine. So we actually found a video of a larger ultrasonic tester that inspects defects on tubes in a very efficient manner. This machine stood out to me in many ways. The first thing that came to mind was the rotating device that has the transducers in them. This device said that it can run up to 4,000 RPMs. And in that video, it looked like it was spinning really fast. And the fact that it's able to make these really precise calculations at that rate is just something that's really unique. Another thing that I really liked about this UT tester was the automation of it. The tubes were loaded up on the one side of it, and an arm lifted the tube in on the conveyor, and one by one, they would slowly go in through the UT machine where they would be inspected. So next up, I have a UT case study, and this actually take place at Salem Tube, which is in Greenville, PA. They are a subsidiary of the Tubicex Group headquartered in Spain. This summer, I was fortunate enough to intern with them as I was a production engineering intern. So what they do at Salem Tube is manufacture drawn to size tubes. So hollow tubes come in, and Salem Tube, with a cold drawn process, draws them to size with a certain surface properties, conditions, tensile strength, and everything. And mostly Salem Tube dealt with cold drawn stainless steel and nickel alloy tubes. So the UT machine was obviously in the quality department, and it was actually the UT at Salem Tube was extremely similar to the one shown in the video. Certain suppliers require accurate quality testing. For Salem Tube's case, they had to supply to SpaceX, NASA, Boeing, and plenty of other companies. They required extensive testing, as SpaceX actually inspected our quality department to make sure we were sending them the right tubes in the best condition possible. A technician is needed to run this tester. Luckily, it's only one operator, which is very efficient, I feel like. A technician typically needs to obtain a UT level 1 certification, but actually at Salem Tube, since we are a subsidiary of Tubicex Group, the person in training actually traveled to Spain and learned on hand how to run the UT, which I felt like was a really cool experience. So next, I'm going to pass it back to Hunter. He will describe some quality testing prior and post manufacturing.
Like we said before, we were going to talk about the quality prior to manufacturing and post manufacturing. So I think the easiest way to describe this is through an example. So imagine cleaning off the acidic chemicals from the process of treatment prior to adhering to another similar piece. The chemicals may ruin the bonding agent's efficiency or compromising the monetary value of the whole piece. Quality check would need to be done to control the amount of chemicals on the surface treated prior to the next step in the process. So it's just showing that quality testing is necessary in between manufacturing processes, post or prior to these enhancement processes, to be sure it doesn't ruin the manufacturing process later down the line. And then basically the same thing for post-manufacturing. For example, after manufacturing many pieces of like aluminum siding for your house, you have an automated system to paint these metals. If the metals are bent or torn or sheared from the manufacturing process, the application of paint may be uneven or even ineffective. This quality check prior to this would be in place to make sure that these metals can be recycled, reworked, depending on the way the workshop's set up. So the important thing to see here in post-manufacturing testing is just to not add more time and money into a product that doesn't deserve it. For lack of better terms, it's just to be sure that we're being as cost effective as possible through the whole process, whether it's manufacturing or surface enhancement or additive manufacturing. All right, so throughout this whole process of looking things over, we found our overall limitations of surface treatments. So first of all, process can only impact cold surfaces, and there's possible wait times when you're working with metals or very hot materials. Secondly, equipment can be very expensive, and consistent acquisition of catalyst materials. So basically the pickling solution, the wax coating, the paint, etc., all these products that you need to supply to do these surface enhancements are very, very expensive. There's also a low tolerance for mistakes due to the permanent nature of surface treatment. So like when you paint things or you heat treat something or you pickle something, it's kind of a one and done kind of thing, so you can't really mess it up. And then finally, there's a lack of specialized workers to conduct specific surface treatments for unique orders. So if you order something with specific treatment type, it might be hard to find someone to do that specific thing because it's such a broad topic. For example, there's so many different ways to treat a product. A sheet metal production company could have like 25 different surface finishes, and some of these are more time consuming and processes may require more time and specialized employees that are trained in that specific area. It's a broad topic encapsulating a lot of variables and factors. It's far from a small venture to take on with the lack of capital and initial resources. After looking at some of the limitations, it's also important to look at the further improvements you can find in the system. Automation is a relatively easy and attainable for most surface treatment processes. So if it's an auto sprayer, auto dipper, or anything that you need to do, it's not that difficult, and there's a lot of automation out there already for it. It's not very groundbreaking. Most treatment processes can be consolidated to one-man operation. So even for a large volume order that may seem like it needs a lot of people, who can normally be treated by just one person through this automation. The treatment process may lose a lot of material depending on type of transformation. Collection and recycling these materials, if possible, for the material type may be crucial for the margins company of lean systems. So basically, these types of systems leave an opportunity to recollect some types of materials or reuse this catalyst materials to its full extent. And I feel as if they can kind of implement these types of processes as well, it may benefit a lot of these processes, because it seems like there's a lot of waste to some of them. Finally, quality control is a must for treatment. So constant improvement upstream will always result in more efficient, concise results downstream. So basically all I'm saying is I think the more quality checks that they do prior to surface treatment, the more efficient that the company will run. There's less reworks, less problems downstream. So I think that a lot of surface treatment processes needs a bit more quality checks involved. But in conclusion, coating, painting, and all surface treatments are essential to business, work, and modern practices. Implementing these practices properly, sometimes challenging but necessary, with the demanding request of varying surface properties in consumer goods. From aesthetics to pure necessity or varying surface equalities, the boundaries will always be pushed to obtain the best and necessary product. So no matter what people do, there will always be some next best thing that we're pushing to do and push materials to the next limit that we can find, just as the Discovery Shuttle is doing here, treating those panels in the bottom of it to be ready to absorb all that heat coming on re-entry of the Earth's atmosphere. That's a very high limit that we push that material to, and we will continue to do that. So that's just an awesome part of this. It's a never-ending lean system that we can try to do with all the wonderful materials around us. Thank you for your time. Here's our references. Thank you.
Good morning, good evening, good afternoon, whatever time it is when you're watching this. Hello, my name is Jared Zillinger. I'm a junior industrial engineering student here taking manufacturing processes with Professor Algera. We're going to go over today the manufacturing of solar panels and all different kinds of facts about it. To start off with a little background, humans have been using solar energy to their advantage forever. Well, not forever, but since the 3rd century, where they would light ceremonial torches using magnifying glasses and start fires for cooking. They really used it as one of their main sources of starting fires. Then, fast forward 1500 years, Charles Fritz invented the first selenium solar cell in 1883, and this really provided the base idea to what we currently use with the silicon solar cell, which is now the primary element used. And the silicon will have better efficiency and availability due to its numerous amount of natural occurrence. The first satellite powered by solar energy was the Vanguard 1 in 1958. That's 11 years before man even stepped foot on the moon. The Vanguard 2, the Explorer 3, and the Sputnik 3 followed with being powered by solar energy, but the Nimbus satellite by NASA was the first to solely rely on solar power, meaning it didn't have any other means of powering itself, whereas you could think of the Vanguard 1, Vanguard 2, Explorer, whatever, as kind of like a hybrid. They had solar power and other power. But that Nimbus satellite was really a revolutionary idea in how it changed the solar industry. Some motivation on why solar panels have been being manufactured and why they're being manufactured more now than ever. It takes us back to the 1970s when we were having an oil shortage, and it really brought attention to the United States that how much we were dependent on foreign resources for oil, coal, the list goes on and on. And the need for innovation was glaringly evident, as if we wanted to become an even stronger country and keep becoming the global powerhouse that we are, we can't keep relying forever on all these foreign countries to keep letting us use their resources. President Jimmy Carter at the time had solar panels installed at the White House, and this really helped spread awareness about what solar panels were all about and showed it was accessible to all kinds of American citizens. And not only were they becoming more accessible and more people were knowing about them, solar panels were becoming better at turning solar power into electricity, and they were becoming cheaper due to their higher production and more availability of materials. Going over some historical facts about solar panels. Since 1980, the cost of solar panels has dropped about 10% per year on average. The Solar Investment Tax Credit, or ITC for short, gives a 26% tax credit to qualifying homes and businesses utilizing the technology. Unfortunately, this number will start to dwindle in the year 2024, but since 2006, it has helped the U.S. solar industry grow by over 10,000%, and that's just since 2006. It's grown over 30,000% since 2000. Sunrooms in homes have been used for centuries to direct sunlight into a concentrated area to warm it. You could almost think of this as a almost octagonal room with magnifying glasses as the ceiling, and they're all pointed onto a pool of water so they could have warm bath water before they had the means of natural gas, electricity, whatever to warm their bath water, so they weren't sitting in freezing cold water when they were taking a bath. Going over some materials of how solar panels, what they're really made of. The basic materials used in manufacturing solar panels really comes down to four key elements. The solar cells, and those are what are really the most important because they're pretty much they're pretty much the heart and soul of the solar panel, as they're the solar cells are the ones who take that solar energy and convert it into electricity. Then you have mostly silicon, or you could have polysilicon. The metal is going to be what really helps protect the outside, usually the back side of the panel, keeps everything aligned, and then the glass to cover the front. And the glass is used as a filter for the sun rays to get to each individual cell, while the metal is used as a frame to protect everything else. But the glasses shouldn't be forgotten as a protectant because it protects the front of the solar panel from getting rain damage. Going into the processes of how solar panels are manufactured. First, you'll want to build the solar cells that are either p-type, which means positively, or n-type, negatively charged. The p-type is built on a positive charge base mixed with boron, while the n-type is built on a negatively charged base mixed with phosphorus. Solar cells are made with crystalline silicon that's melted and mixed with gallium and boron to form silicon ingots. Ingots are then cut into thin sheets, and an anti-reflective coating is applied. An anti-reflective coating is applied to capture sunlight instead of reflecting it away. So, without this anti-reflective coating, the solar panels would be almost useless, as they would just act as mirrors almost instead of sponges. The solar cells in the solar panels become semiconductors of electricity due to the photovoltaic effect. And then also, thin lines are cut into the cells to capture and move current within the cell. Without them, they wouldn't be able to move around. And then we'll go over about monocrystalline versus polycrystalline. Monocrystalline panels are formed from one silicon fragment, and it's just the entire panel, and it's cut thin lines into it. Or the polycrystalline panels, they're formed from melting many silicon fragments together to make that big panel that is then cut into pieces. The next step of manufacturing solar panels is to solder the cells together. This is really what forms the panel, and it's especially important in the polycrystalline panels. Usually 60 or 72 solar cells will form one panel, but although most solar panels most often have 60 or 72 solar cells, other configurations contain either 32, 36, 48, 96, or 144 cells. These will be assembled in rectangular fashion to form one panel. And if you didn't know what soldering is, it's a process similar to welding, but it's used for joining metal parts to form a mechanical, or in this case, an electrical bond. Going over step 3 of the manufacturing process, we're going to go over the installation of the backsheet. This protects the bottom of the solar cells and is made of a combination of polymers. Backsheets are important and help prevent accelerated system degradation, unwanted maintenance, and part replacements. Without this backsheet, your solar panel would be falling apart off the bottom, high winds would be breaking pieces, and you would have to go out there all the time and have to be fixing stuff and replacing parts. So the backsheet is a very vital part, as all of them are, of the solar panel. And then also, bifacial solar panels, which isn't captured here, but those are solar panels that allow sunlight to enter from both sides. So in some instances, the backsheet isn't a stainless steel or metal sheet, it's a clear, transparent sheet, because the sunlight has to enter from the back as well as the front. Going over step 4 of the manufacturing process is the installation of the glass front. This allows light to filter through to the solar cells and protects the solar cells from weather-related degradation. Without the glass front, things like rain and strong wind would severely damage the solar cells. And also, the material of the front has to be glass due to its transparency. A material such as aluminum wouldn't be effective at all, and we kind of went over that in the last process about having, if the solar panel was bifacial, it would have to be transparent as the back sheet. Going over the 5th step is the sealing of the metal frame around the panel. The metal is used as the frame due to its high strength and low cost compared to other materials. It uses silicon to fuse all of the layers together, but then the metal is used to really lock it all in place, and it helps in the protection of the panel. Without the frames, without the frame, all of the layers would easily fall apart, making the solar panel ineffective. Going over the next step of the manufacturing process is the installation of the junction box. This protects and organizes all of the electrical wires in the back of the solar panel. Frank Rosenkrantz, product manager of solar for EMEA Indian Americas for connector and junction box manufacturer TE Connectivity, described the junction box as the most important part of a panel. This is almost like your engine of a car. Yes, you can have wheels, nice heated leather seats, but without that engine, the car isn't going anywhere. Just like the junction box. Without the junction box, solar energy can't be converted to electrical energy. It also ensures that the current doesn't go back into the panels. It makes sure it's drawing out the solar and electric energy out of the panel. They're usually made of metal, but they can be made as plastic as well. As common with many other parts in the solar panel, this part is essential in making sure the solar panel doesn't get damaged due to weather, due to the fact that it protects the electrical wires. Going over really the final step of the manufacturing process is quality control. Although we pretty much already have the solar panel built, we want to make sure a functional product is being put into the marketplace. We don't want any defects to be out in the public, and that's what the quality control allows us to iron out those defects or slight issues with the product before sending it out. Quality control is one of the most important parts of manufacturing, and if you don't take this detail in the process seriously, it can lead to costly lawsuits down the road. We're going to go over some additional details related to solar panel manufacturing. As far as location, solar panels are made all over the globe, but Asia really takes precedence. Many industries have moved manufacturing to Asia due to lower labor costs, and solar panel manufacturing is no exception to this rule. While not all higher quality solar panels are made in the US, most of them are, and they're made by companies like Panasonic and Mission Solar. In looking into the future of solar panels, people are looking into the design of panels that track the sun and angle themselves so they're always facing the sun. This will allow them to absorb as much energy as possible, rather than missing those crucial hours where the panels are faced the wrong way. We're also looking into decreasing the cost of solar panel manufacturing. With the cost decreasing year after year, they'll only become more practical, and this will likely lead to solar panels becoming a leading source of electrical energy, overtaking coal and natural gas. Right now, adding more layers of solar cells increases efficiency greatly, but increases cost and difficulty of manufacturing too much to be justified. When manufacturers figure out how to do this easier and cheaper, it'll be huge for the solar industry and allow solar panels to really take off as that main leading source of electrical energy. In conclusion, you can, as simple as this may sound, you can compare the process of manufacturing solar panels to making a sandwich. You have to take it one layer at a time. The order of layers matters. Just for example, you wouldn't want both slices of bread on top of each other and then all the meats, cheeses, and vegetables above that. That wouldn't make a lot of sense. And each different layer has different purposes. The bread can be thought of kind of like the back sheet in the frame. The meat can be thought of as the solar cells, and say the lettuce and tomato can be thought of as the glass. Here are some references used for this slideshow. Thank you for watching, and I appreciate your time.
Hello, my name is Laura Cárcamo, and today I will be presenting about the food and beverage packaging processes and understanding the selection procedure for the manufacturing processes class. This is the table of content of some of the topics we'll be discussing. Food and beverage packaging is the foundation of the modern food industry, considering very few foods are sold on package. Good packaging prevents waste and ensures that the food retains its desired quality throughout its shelf life. So despite its importance and the key role that packaging plays, it is often regarded as a serious waste of resources and an environmental threat. Such views arise, though, because by the time most consumers come into contact with a package, its job, in many cases, is almost over. The product is safe, and for the consumer, that's all that matters. But it's much more than that. I have always been interested in food and beverage packaging because growing up, my aunt worked with one of the many bottling companies. So she would take me for the Coca-Cola company. So she would take me to the plant and I would like look at how the process worked and I would always be in awe and like amazed on how organized and how efficient the plant was. So when I found out that this was one of the topics for this project, I was really eager to research and learn more on the topic. The role of packaging. The consumer's experience with the product itself is greatly influenced by its packaging. Some questions packaging engineers must ask themselves is it easy or difficult to open the package? Is the product kept fresh by the materials in which it is packaged? Also, is the product in one piece as intended or broken into tiny pieces by the time it gets to the consumer? And lastly, is the product contaminated? Because of this, there are four primary functions of packaging that should be addressed in packaging productions. The first one is product protection. So the main goal of product protection is to keep food safe during transportation, handling, and distribution. Common packaging solutions such as glass, rigid and flexible plastic, aluminum, and cardboard may be used in combination. For example, bag-in-box packaging applications are used for both food and such as cereal or rice and beverage such as wine. And then we have aluminum, which is suited for cans of soda and to give food containers a premium look and feel. Now let's talk about product safety. Packaging ensures product safety to eliminate or reduce food recalls and hazards, as well as help with traceability. Food products contamination can occur at any point in the supply chain. So as food and beverage companies begin to grow, it is critical to maintain control over the supply chain. There are several packaging processes and technologies designed to help increase food safety measures. While using food-grade materials is mandatory, there are still hazards that can occur at the packaging stage. For example, inks and coatings used on packaging can migrate into food and beverage products. That's why the FDA has a lot of regulations on this type of packaging to ensure safety. Now we have product freshness. Proper packaging can increase a product's freshness and maintain its appearance, taste, shelf life, and quality. Some ways a company can increase a product's shelf life and better control product's freshness is materials, also film barriers. So in flexible packaging, there are different barriers, properties for air, moisture, and flavor. Coatings can be added to films to change and extend the product's shelf life and enhance freshness. Some food and beverages require a barrier, some such as meat products require breathability in the wrap, so it all depends on what product we're talking about. And lastly, we have resealable packaging, which is typically in the form of a zipper, lid, or label closure. So this type of packaging helps maintain product freshness by locking out air and adds convenience for the consumer. Now let's discuss packaging selection and design. So shelf stability, the rigors of transport, product-package interaction, and sustainability goals are just a few of the incredible number of considerations when choosing packaging materials. Testing and retesting are essential. There are multiple categories of packaging. Typically, we look at three primary, which is the primary, the secondary, and the tertiary. Each layer or each type of category performs specific purposes, and selecting the right properties is key. So let's take a look at the elements involved in selecting the right packaging. So first we have primary packaging, which is the most important one because it's the one that holds and it has direct contact with the product. So as the primary packaging is in direct contact with your product, here are some key things we should consider. So first of all, we have stability. If the product is affected by exposure to light, temperature, oxygen, or moisture, then the primary packaging needs to protect it from degrading while in transit to the consumer. So it's important to analyze the stability of the product. Also, we have flavor, odor, and color. So proper research is needed to prevent packaging from affecting the final flavor, odor, or color of the product. For example, the product cannot absorb odors or flavors from outside of the package if it has no barrier properties. Also, we have performance. How will the consumer want to dispense the product? Will it spray, squeeze, pump, or pour? With will all the product dispense out? So the mechanics of the packaging are more complicated than, say, a twist of the lid on a jar of peanut butter. A real-world example or a case study for primary packaging is a bag of chips. So individual serving sizes of chips include a dose of nitrogen for two reasons. First, the one to keep them fresh and flavorful and to protect them through transport. However, here's another twist. Chips that are destined to be stored and served on the flight must have less nitrogen than those that will travel in the back of a truck and wind up on a shelf in Walmart. Why? So at altitude, the gas will expand and the bags will eventually burst, so the destination becomes part of the calculation. Now we have secondary packaging. So the decisions made here will depend mostly on the role of secondary packaging will play. So we don't really know what the role will be. It all depends on what specific type of product we're talking about. For example, how will it sit on a shelf, or how does the secondary packaging display play a part in tamper proving? So perhaps we need it to be a certain size to house multiple languages worth of ingredients or instructions for use. So let's consider a cold drink on a hot day. So beer distributors store products at temperatures just above seasonal point levels of temperature in order to prevent condensation on the primary package from damaging secondary packaging during transportation, affecting salability. And lastly, we have tertiary packaging, which is the packaging that wraps up all of the final products in order for them to be shipped and handled. So storage, handling, and shipping all affect products and packaging. Understanding the journey that is ahead, the storage, mode of transport, distance, temperature, and humidity changes and vibrations will all affect the choices you make here. So it's really important to have R&D testing, which is a process of experimentation to eliminate or resolve technical uncertainty. So it is essential to any packaging exercise, putting the individual and combined layers through rigorous testing for things like shelf stability, product-packet interaction, and the ability to handle shocks, drops, vibrations, temperature, and humidity will help inform a decision and hopefully avoid any surprises. As years have evolved and technology has been updated, a lot of new materials have been introduced into the food and packaging industry. However, these are the main materials we use nowadays. So first we have plastics, which are easy to mold into desired shapes. The good thing about plastics is the lightness and versatility of these have given plastic a big part in the processing and packaging of food. Also, it has a low cost and low energy consumption during manufacturing. So it has replaced a lot of traditional packaging materials. In addition, they're able to preserve and protect the food for longer, which minimizes the use of preservatives. However, although plastics are considered recyclable materials, they're not good for the environment because they're pollutants. So in the plastic manufacturing processes, there are many varieties of plastic resins. The three most used are PVC, which is very resistant to humidity, fats, and gases. We also have PET, HDPE, and LDPE. This is called the PET range, and it has revolutionized the packaging industry, allowing plastic to compete directly with glass bottles. And lastly, we have PS, which is the plastic of choice for thermoforming goods with strength, malleability, and low cost. Next, we have metals, steels, tin, and aluminum. The main use of these metals is the preservation of canned foods and beverages. The most commonly used are tin-coated steel and aluminum cans. Since it's an opaque material, it provides an advantage for food that is sensitive to light. Thin-walled aluminum cans are suitable for carbonated beverages, And it's also good when they contain products with low pH. Tin cans are perfect for this stuff. Now, next we have glass. So glass is an inert material that is impermeable to gas and vapors. So it is an excellent and completely neutral oxygen barrier when it's put in contact with food. However, it is really fragile and uh, it is really expensive to manufacture and also to ship and handle. Next, we have wood, cardboard, and papers. So products derived from wood are widely used in the packaging of food in the form of paper and cardboard. So paper is a very cheap, lightweight product with excellent printing capacity, although it is very sensitive to moisture. But it can be corrected with a combination of paper and other materials such as plastic or paraffin. Cardboard is mainly used for boxes, which is harder and more resistant than paper. And in recent years, paper and cardboard manufacturers are paying special attention to issues related to health and the environment by working with recycled products that increase the useful life of these raw materials. So for the facility and packaging suite, which is the space that holds the equipment and the people needed to get the product into a package, the following factors should be considered. The first one is how the room operates. So mapping how the product, packaging materials, waste, and people flow through the space is the first step. How much space will be needed to accommodate the line? Will parts of the line be automated or will it be completely a manual process? How many people are needed to operate the line and what space do they need to do their work? It is also really important to consider where will the supplies be stored and how will they be moved out of storage when needed, and also how the company will manage waste. Another factor we should consider is business needs. So nowadays, thanks to technology, a simulation software is available to support decision making during the design process. So modeling allows a company to compare the relative efficiency of different equipment models and can help forecast volume and determine shift lengths between changes over. Feeding procurement information like delivery schedules and volumes for raw materials, and they could be able to foresee potential bottlenecks or downtime. Modeling software is relatively inexpensive, and with the right inputs, the information can provide a real guide and can guide to confident decision making, which is really important if we want to save money in the long run. And lastly, we have health, safety, and maintenance considerations. So the goal of manufacturing is to optimize output. A key to minimal downtime is good maintenance. It should go without saying that but employee safety is also really important, not only related to the equipment but overall operations within the area. So designing in steps for employees to be clean, hygiene, and equipment sanitation is in the operation of the facility will mitigate food safety risk. So what's ahead for this fascinating and complex industry? What will drive food packaging process and line design into the future? So first we have regulatory requirements. So the Food Safety Modernization Act, FSMA, has shifted the focus of regulation from responding to food safety issues to preventing them. So now they're preventing them. They're not just acting when something happens. They're straight up preventing them. Next we have sustainability. So the drive to more environmentally friendly processing and packaging continues. Consumer demand and corporate responsibility are driven sustainability efforts in food packaging, with processors developing proactive solutions to reduce environmental impact, from comprehensive waste stream management plans to compostable and biodegradable packaging. Food processors are rising to the challenge with new innovations. And lastly, we have automation. So the pandemic led many to rethink how a line can work with fewer people, more spaced apart. The result is an increase in automation that may be here to stay. Automation provides several benefits, reducing manual labor, decreasing operating risk, and lowering operation costs. But it's not without its limit. The short story is, this isn't a short story. Food packaging is an incredible complex field that requires know-how, planning, and understanding of the cascading efforts of every decision along the way. Here are some of the references I used. Thank you so much for your attention. Have a great day.
Hello, my name is Michael Mastors, and today I will be presenting about good manufacturing practices. So this is just an introduction of what I'll be covering, the topics I'll be covering. I'm going to start off with the motivation of why I selected this topic. Then I'll go into the background and history of good manufacturing practices, and then I'll go into the procedures of the good manufacturing practices, and then go into the consequences of not using them, and then show an example case study, and then go right to the conclusion. So to start off, I'm going to be talking about the motivation, and the main reason that motivated me to pick good manufacturing practices, otherwise known as GMPs, as my topic is the fact that it correlates with industrial engineering. Industrial engineers are usually focused on optimizing complex processes, systems, or organizations by implementing unified systems of people, knowledge, equipment, and information. Similarly, GMPs are a system of guidelines that help with methods, equipment, and facilities and controls for production. So in my mind, they almost correlate in the fact that in both of them, you're trying to create a product and create it to the best of its ability in the safest and most simplified manner. Next, we're going to talk about exactly what are GMPs, and good manufacturing practices, otherwise known as GMPs, is a system for ensuring that products are consistently produced and controlled according to quality standards. It is designed to minimize the risks involved in any production that cannot be eliminated through testing the final product. GMPs are the regulations for many different products, including medical devices or products, processed food, human and veterinary products. You could have GMPs in canned food such as like soup. You could have it all the way to like medical cream for a rash or something like that, along the lines of anything like that. GMPs are used to eliminate error, produce products of consistent quality, reduce recalls/rejects, to satisfy customers, protect the image of companies, and because it is a government requirement. And on the right here, we have a picture of good manufacturing practices, which yields good quality. And it's basically the procedures or the parts of good manufacturing practices, and some of them are personal training and competency, management commitment and continual improvement, risk management, quality management systems, site and facilities management, and product control. And I will be going over those in the next few slides. We now have the history of GMPs. This is just a brief history of like the most important dates. And before 1962, there were actually no GMP requirements or laws until 1963, which was when the first GMP regulation was implemented in the United States. GMPs for manufacturing, processing, packaging, and holding finished pharmaceuticals were first published in 1963. Later in 1978, the GMP regulation was revised and rewritten. These revisions established minimum current GMPs for manufacturing processing, packaging, and holding drug products and medical devices. Later in 2002, GMP for the 21st Century Initiative introduced the new FDA technique for routine drug manufacturing inspections, which focused on 2 or more systems. And this is the latest revision, which was in 2002, and is actually the same GMPs that we use to this day. Now we have the procedures or parts of the good manufacturing practices, and the first one being environmental control. The location, design, and construction of the building and its interior are very important. The factory buildings of which the products are manufactured should be established in a manner that avoids 1. The risk of contamination from external conditions, accounts for smoke, chemical emissions, fumes, or odors, bypasses any mix-ups or contaminations, is arranged to have enough workspace, and has adequate lighting, ventilation, etc. So basically, it's just very important to have a safe environment it talks about, having avoiding risk of contamination, which could lead to severe injuries and death. Um, Same with, not having enough workspace. You want to make sure that there's enough room for all of the equipment so that everybody's working comfortably and safely. And in this picture is a hazards and safety features diagram, which is basically a layout of a factory and just showing how everything is set up nice and neat and organized with enough space, and shows the doorways and the different stations and etc. to make products. The next procedure would be personal practices. Personal hygiene. All workers are responsible to make sure that the hands are clean and should be washed after using the restroom, eating or drinking, and upon entering work. Um, the next part of personal practices would be clothing. Everyone should make sure that they wear correct outfits for the task that they, have at hand, and such as the correct protection for certain products that can put them at risk, whether that be, chemicals or products that are, heavy or sharp. They should be wearing, a hard hat or steel toe boots or gloves, and if they're working with chemicals, they should have, all their skin covered. Next would be injuries. Employees should make sure that if they are hurt or have open wounds, they have seen a doctor to know whether or not they should be okay for work. You don't want to be coming into work with an open wound and being exposed to chemicals that could infect that, and who knows what could do to you. So, the next and last thing would be illness. Staff that are ill shouldn't be examine any starting materials or finished products, and for that case, you shouldn't even show up to work if you are ill. And on the right, we have a food safety and personal hygiene. This just shows, an example of a chef that's coming into work, and you shouldn't have, your hair showing for the first example, hair showing, no earrings or necklaces or chains, no outer pockets, cover all wounds, nails should be clean and short. So it's basically just showing you the correct things versus the wrong things with hair coming out of the cap, because you want to dress appropriate for work. The next procedure would be shipping, receiving, and handling and storage. There should be inspections of the procedures for transporting vehicles that have, the goods or the products. It is important to have sufficient areas for loading, unloading, warehousing different materials and products, storage conditions, and etc. Also, supervision is needed for incoming products, shipping conditions, returned and defective products. Disposing sewage and other liquid waste should be supervised and follow the specifications of the Environmental Pollution Control Board. All the waste management should be recorded and done regularly. Um, so just everyone needs to make sure that they, keep track of what they did when did they do it, and make sure that they're doing it, regularly to make sure everything is caught up. On the right here, we have a picture of a chemical storage. So they would store chemicals that they're using in the production, and these could be found inside the factory, or they could have larger ones that could be outside the factory. And then down here is just showing the neatness of, storage and the organization that is being supervised and should be maintained like this. Next, we have pest control. Pest control sort of falls under the environmental control category, as the building should be designed to keep pests from entering and to avoid the surfaces with cracks. Um, so, obviously they're going to want to make sure that everything is tight, and if you have cracks, that could lead to, bugs and insects and stuff getting in there. All procedures for the interior and exterior of the building should be monitored with surveillance. If there were to be a report of pests on the premise, many different control methods could be used, such as trapping, which would be, trapping with cages, like if you had raccoons by the trash cans or whatever, or mouse traps to stop mice. You also have pesticides, which is a substance to repel, kill, or control, insects or any pests. Fumigation, which is a gaseous chemical, which is more of a extreme measure that would require, the clearing of the factory or building. And then lastly, the biological pest control, which is the use of living organisms or finding, the organism's enemy or something that could take out the other pest. And then right here we just have a simple diagram showing like somebody using pesticides to take out some sort of insect, and you could use that with many different pests. Next, you have sanitation. Sanitation is cleaning and sanitizing are critical procedures within a production, um, especially to stop cross-contamination. The premises for manufacturing should be cleaned and maintained according to the certified cleaning procedures. Um, these areas shouldn't be used as storage or walk-through areas to avoid, any problems or dust or buildup or cross-contamination. Next, a routine program should be, or a routine program for sanitation should be designed and observed, just to keep everything in track again and make sure everything is checked on, occasionally and, on a certain schedule. On the right, we have a picture that is saying what's the difference between cleaning, sanitizing, and disinfecting. Cleaning is just removing dirt and debris from surfaces through hand washing or mechanical cleaning processes, while sanitizing is reducing the number of germs, bacteria on the surface, and objects to a safe level as judged by a public health standards or requirements. Disinfecting is for chemicals. Disinfecting destroys or inactivates bacteria and viruses that are clearly identified on chemical products labeled on hard, non-porous surfaces. Other means, such as steam, can also destroy or inactivate bacteria and viruses. So this just shows the difference between these three. Next, we have equipment maintenance. Equipment should be designed, constructed, located, and maintained to fit the procedure that it is being performed. The layout of the equipment should be designed to minimize the risk of error and allow for efficient cleaning. All equipment should be labeled according, and when a piece of equipment becomes defective, it should be taken out of the workspace that the other materials are in. It is important to make sure that the equipment has scheduled maintenance and is calibrated in order to keep operations precise. So basically everything that you have noticed in these procedures is really making sure that you're on it and having a weekly or monthly schedule of checking up on things and making sure they're all running and staying clean. Below is a picture of equipment maintenance, and it's just showing how everything is organized, and they have a scheduled maintenance here and showing the different stations basically and how everything is organized and spaced out in the production. Next, you have the recall and traceability. There need to be procedures that ensure final products are coded and labeled properly. This also means that materials that were used in the process of production and materials that are outgoing are traceable. Records for distribution should be maintained in an orderly fashion so that the finished batch can be traced to the retail level if there were ever to be a recall. A recall system must be in place and tested for effectiveness. This should include things such as distribution records to be available for designated recall. The recalled product should be stored in separate areas, and written procedures of action to be taken if there were to be a recall. So it is very important to keep everything organized just in case you were to have a recall so that you had everything ready and you had everything tracked to know where it was going or where it's at. On the right is a little diagram showing of recalls, just a simplified version showing the product identification, locating the product, and then returning the product back that is on recall. Next, you have water safety. This is the last of the procedures. The purpose of water safety plan is to protect the health of humans and ensuring a good water supply. There should be a water safety monitoring procedures of valid systems for treatment of water to assure that it is potable, which means safe to drink. The potable water should be used within all operations other than cleaning and washing. The storage tanks for the potable water should be cleaned on a schedule and be recorded. So this image on the left is a storage for potable water in a large factory or a large volume of the potable water. And below is a storage that you might find inside the factory with a smaller volume of the potable water. So next, there's two types or components of GMPs, which is written and implementation components. GMPs or written programs are policies or procedures required to meet the standards listed in each GMP program. Some examples would be monitoring procedures, recording, record keeping, sanitation operation procedures, and then implementation would be conducting of the activities necessary to meet the standards in monitoring them. To make sure the policies are performed, there needs to be training of staff members. So training all employees, make sure all employees meet the requirements, review records and procedures to ensure that they completed properly. So really the major difference is that the written programs are the policies and like procedures that you have to follow while making the production, while implementation's actually like conducting the activities and actually making sure somebody's trained for those procedures or policies. So next is the consequences of what would happen if you didn't follow the GMPs. And there are many risks that follow if GMPs are not implemented. Some of them being unanticipated contamination of the products or materials can cause damage to health and could even lead to death. If labels on specific containers are incorrect, this can lead to people getting the wrong medicine. If a specific ingredient is added to a product with too much or not enough of the ingredient, it can result in ineffective treatment or negative effects. If a customer is unsatisfied with their product, this leads to the company taking a huge hit on their reputation. When a product is dangerous and puts consumers at risk, their product will most likely have a recall. So it's very important to follow the GMP structure and make sure that everything is following their rules, because if not, it's most likely going to lead to a lot of risks that can hurt your business. So here is an example case study. This is like a 3-minute video, 2.5-minute video explaining a case, and then we'll go over it after. So basically, it's explaining that they messed up on their product and they know they did, and um, it could have been very bad if it wasn't just a cream and they, used something that was more life-threatening. So after watching the video of this case, the company, Intelligent, made a huge mistake and could have left many people in bad health or even led them to death. The first thing the Intelligent should have done was created a root cause analysis to find out where the impurities originated. There could have been something wrong during the preparation of the product, or the procedures just needed to be updated. The next thing they should have done was to identify the impurities to prove that they didn't come from the product itself. The third step should have been to prolong the investigation to make sure that the other batches didn't have the same impurities. So, Intelligent made many mistakes along the way, and they need to review this case so that they can correct the mistakes. And this leads me to my conclusion. So, in conclusion, good manufacturing practices, otherwise known as GMPs, is a system for ensuring that products are consistently produced and controlled according to quality standards. This system also allows for protection of the customer while regulating environmental control, personal practices, shipping, receiving, handling, storage, pest control, sanitation, equipment maintenance, recall and traceability, and water safety. It is safe to say that GMPs are necessary when creating products as they meet the legal requirements and minimize the risk for contamination, mix-up, and errors. So that is the conclusion of my presentation. At the end of the day, I think good manufacturing practices are a necessity and they could save the lives of many others and save them from risk. Here are my references that I used all throughout the slides. I was going to cite them, but I used multiple ones on each page, so here are all of them at once.
Hello, my name is Pasquale Lorelli, and this is the Coca-Cola packaging process, and I'm here with my partner,
Jake Pitzer.
And this is our project number 1. Okay, so the motivation for the Coca-Cola packaging process is that renewable materials should be used so that they can be recycled and reused. And Coca-Cola has in mind cheap and easy production so that they could save as much money and produce as many cans as possible. And the motivation behind the plastics that they use is a plant bottle, and this is to reduce their harmful environmental impacts in regards to carbon emissions and other things. Okay, so the history of Coca-Cola. So in the year of 1886, a local pharmacy man by the name of John Pemberton created his famous concoction, and it originally had cocaine in it, as it wasn't illegal back in those times, and it was seen as a stimulant and a remedy for many problems such as dietary and nausea and energy. And so he brought his concoction down to a local pharmacy, and they sold it as a remedy, and started to gain popularity. In the first few years, they only sold on average 9 sodas a day. So came from humble beginnings. Shortly after, he died from stomach cancer, but before the time of his death, he sold his stake of the company to Asa Candler, who saw a lot of potential in this drink, and he ran with the idea and was a very good businessman. And shortly after, in 1919, Asa Candler sold his business, Coca-Cola, for $25 million to a few investors who took the company public that same year, and Coca-Cola became a publicly traded company. And in 2006, the Coca-Cola company introduced plant bottle packaging, which is the world's first bottle that uses plant matter to create the plastic. And later, in 2015, they came up with a prototype bottle that uses 100% plant matter, but we have yet to see that be introduced on a wide scale to the public market. Okay, so the background. Coca-Cola is a multinational beverage company, and it is a publicly traded company, as we talked about, in the year 1919. And Coca-Cola is a conglomerate owning over 200 company brands such as Powerade, and Fanta, and those types of drinks. So almost half the drinks that you see on the shelf are usually owned by Coca-Cola in regards to sodas and energy drinks. So there is a picture of Coca-Cola's publicly traded symbol, and it has the market data since the year 1987. So manufacturing methods for packaging for Coca-Cola's product is there's 3 types of manufacturing for their packaging, which is plastic bottle manufacturing, which involves blow molding, aluminum cans, which involves draw and iron body manufacturing, and glass, which uses press and blow processes. So, as seen in the picture, that is a can track which has all the finished bottles of plastic Coca-Cola bottles. Okay, so method 1 for manufacturing, which is plastic bottles. So blow molding is the main process used in creating plastic bottles. So plastic pellets are fed into a machine, and they are heated until they melt. And then a small amount of the plastic that is melted is placed inside of a tube. And then this is clamped in place inside of the mold, and it is blown up using compressed air that inflates the plastic mold to the inner walls of the mold of the shape of the bottle, and then it cools, and this is how your plastic bottle is made. So as you can see in the picture, the tube of air expands the plastic mold into the bottle shape that you see. So to elaborate on plastic bottles, plant bottle technology, which is fully recyclable and it reduces carbon emissions. And this process uses cane sugar and molasses to make a major component in PET plastics. So this saves petroleum, which is harmful to the environment and is not renewable as quick as, let's say, cane sugar. And so these plant bottles are made from 30% plant matter. And they're what are used today in Coca-Cola bottles all around the world. So methods, aluminum can manufacturing. So the pros of aluminum can manufacturing is that they're durable. They do not deteriorate like plastic. They are lightweight, and they're more durable than glass. And so the cons are that it's more expensive than plastic. It's 25 to 30% more expensive than plastic. And it can alter the taste a little bit more because the aluminum taste could come through in the can and it could show in the drink. And chemicals that spread into the drink also from the fluoric acid bath that they take to clean the cans. So I will pass this on to Jake, where he will take over the rest of this presentation.
Yes, thank you, Pat. Before I start, I'm like slightly hoarse, so hopefully it doesn't cause any problems. I'd like to apologize. So at the start of the process, the manufacturers gather a large aluminum roll in an insane like bulk size. The aluminum roll is so large that it can make 750,000 cans, plus have a bunch of excess metal. So from here, this sheet metal is put onto a conveyor belt and rolled into a press And this press performs two functions on the metal. So it produces a 5.5 inch diameter circle that's cut out, and then it bends the aluminum to make that second image down there. And as you can see, there has to be some bend there to develop that shape. And yeah, this excess metal is then sent to the scrap, where then it is reused in the aluminum rolls that were initially used in the process. And then so the cup goes into a machine, or I guess the base of the cup, called the draw and body maker, where a tool draws out the aluminum forming the body of the can. And as you can see in the image, the can at this point is just extended. And that's when the metal itself obviously thins out, but it takes on the same size as it would when the consumer receives the can. And this toll is lubricated, so it won't tear the can. And it also acts as a coolant, since at this point it's obviously you're dealing with aluminum, which is a strong conductor, so it develops a decent amount of heat. Pat, can you please move to the next slide? Thank you. So the cans are then transported upside down on the conveyor belt to the washer. This is so it can then continue with the 6-stage cleaning. So the 6-stage cleaning begins with the first 2 stages are hydrochloric acid sprays, and they are done at a fairly high temperature. And this is so the can gets its shiny finish by taking off the top layer of aluminum. And the last 4 are in deionized water, and this is to prevent the harmful chemicals from being in the products once it reaches the consumers. And you can kind of see on the left side the water spraying in the second image down on the cans. So the cans then, can you go back 1 second, Pat? The cans then come out of the washer and onto a hot air dryer, and at this point they're ready to begin the painting process. So here the roller passes over the cans and coats the bottom rims with a varnish, and this is so that they easily slide through the conveyor belt, as well as the vending machine when they eventually get transported there. And then the cans finally go through the painting system, where it paints the labels onto the cans. The rate at which this is crazy. The rate at which the cans are painted is 1,800 cans per minute, which obviously is great for their efficiency. So at this point, the cans are obviously wet from the paint, so they slide through an oven, and it instantly hardens and dries the protective varnish on the paint. So after going through the dryer, the cans slide into another machine that sprays a water-based varnish on the inside of the cans. Now, this sprays on the inside of the cans to create a barrier between the drink and the metal. This stops it from having an aluminum taste when the consumer drinks the can, obviously, and it also prevents from the metal deteriorating from the acid in the drink. And in the case that it wasn't there, obviously, a consumer would have a bunch of harmful products inside of them. And then so the cans go through a machine called the necker in the second image, and the necker is what forms a 2-inch neck on the can, so the cans don't easily puncture. And if you just think about an aluminum can, you can feel the thickness at the top of the can versus in the middle of the body. And that's a means of durability. And then it's transported to the flanger, and the flanger forms a curved edge over the top of the can, and that's where the tab is then added to the top. Okay, so at this point, the cans are then tested through a vision system. So this is where they look for any like damaged physical features to the cans or any, for some reason, ink on the inside of the cans. And obviously, if they find these things, the cans are removed, and only the good cans are then transported to be stored and stacked for eventual use. And at this point, there's no Coca-Cola in the cans. So, in conclusion, Coca-Cola packaging is a mesmerizing process and involves automated machines that produce a high output to keep up with the worldwide demand. And yeah, since the machines, like, throughout the whole process, there were very minimal human interaction. And obviously having completely automated machines, this drives a profit through the roof, not having to dish out money to workers, and which is probably one of the main reasons why Coca-Cola shares are so high. And I'm sure that gives us like a larger dividend back to the investors at the end of the day. And as Pat previously mentioned, Coca-Cola is more than just a beverage company, and they have their hand dipped in every pot. Like they sell teas, waters, obviously sodas, but they even do with a lot of like merchandise, like a lot of Coca-Cola. A lot of people have like a Coca-Cola collection of just various products with like a Coca-Cola label on them. So I think that's another interesting about them. And then aluminum is a safe, reliable, recyclable, and relatively cheap storage unit for Coca-Cola. And comparing it to the other methods, I'd say aluminum is the most durable and cost-efficient way to manufacture Coca-Cola product. And they have a bunch of means of doing so, but their reasons behind it could be the aesthetic, environmental issues, anything. And what could be improved in this process? I think that the fact that Coca-Cola makes the cans and then stores them obviously takes up a lot of space and adds a lot of time to their process. So it also adds some more risk to the process as well. So I think they could improve their process by cutting out the just storage of empty cans, and before they're stored, import the beverage into the can, and then ship it directly to the retailers that sell the can. Obviously, this would save a lot of time and money, and that's about it.
That's our works cited page, and those are the references we used.
Thank you, guys.
Thanks for your time to listen to our project.
Hello, my name is Sarah Baca, and today I will be presenting my project on recycling processes and their impact on industry. The list of topics that I'll be discussing throughout this presentation are the definition of industrial recycling, processes involved in industrial recycling and how they are applied to different types of industrial materials, and lastly, the overall impact on the United States and the world as a whole. So to begin, the definition of industrial recycling is just the conversion of industrial wastes into materials that can then be reused in production. The United States is the third largest producer of industrial waste in the world. Overall, the country produces over 8.4 metric billion tons of waste annually, but only 258 million tons of this comes from consumers and everyday just solid waste produced by households. The other 8.4 is produced by industrial sector, medical, and agricultural industries. Of that 8.4 million tons, only 30% is currently recycled on average. So the vast majority is not recycled. And this has implications on civilian health, people breathing air pollution or water pollution, sustainability, ruining the nature and the environment around these industries, management of waste with disposal costs and how that affects the company directly, and then cost savings for the company. The amount of waste can have a huge financial implication for these companies. In the US, the Environmental Protection Agency regulates waste disposal to protect humans and the environment. So a little bit about the background of trash collection and recycling in the United States. And back in 1885, the US built its first incinerator. That was not a recycling process, but it was their first kind of commercial way of handling large-scale waste. In the 1960s, the Solid Waste Disposal Act was passed, and that was the first kind of conscientious move towards the government getting involved in resource recovery and recycling type processes. In 1968, 33% of waste was then being separated into recyclable and non-recyclable categories. And then that leads to the 70s when the EPA was founded and resource conservation acts were passed to emphasize more focus on recycling and conservation. So the most commonly recycled industrial materials are listed here. We have glass and plastics, and then you've got oil, chemicals, batteries, digital waste from computers and devices, construction materials, coal combustion products, foundry sand, scrap tires, and scrap metals, which are like your copper, steel, and aluminum. And generally, these materials go through 3 different phases, which involve collection and then some sort of processing specific to the type of material, and finally recovery, which is just the harvesting of the usable materials at the end. So now I'm going to go into specifics about some of the most widely recycled materials, starting with oil recycling. So the source of oil is primarily automotive repair shops and car dealerships. So when you think about like an oil change or something like that, and it goes through the following process. It starts out with the analysis and testing to see if the oil that is being recycled is able to be further refined. If it passed that test, then it goes into the refinement process, which involves separating water in the oil and chemicals. Refinement is broken down into 3 stages. There is dehydration, defueling, and then vacuum distillation. And at the end of all of this refinement processing, the oil is then put through hydrotreating, which is the reduction of any carbon, acid, sulfur, or nitrogen still contained within the oil. Over in figure 1, you can see some of the machinery that would be used in this refinement process. So the impact on industry is that recycling of the oil can bring many benefits back into companies. They can use repurposed oil to reduce electric bills by using it for heating and cooling. They can reuse the oil by applying it to make energy, to manufacture and process raw materials, even using it to run engines and machines. And overall, the biggest impact would be reducing the threat of spills and environmental contamination. Process 2 is scrap metal recycling. Scrap metals can commonly come from the automotive, construction, railroad, or equipment industries. And it again follows this following recycling process. So starts out with the collection, and then the biggest thing about metals is that there's so many different types, so they have to be sorted according to the type of metal. So they go through a sorting process, and then they go through processing according to the type of metal that they are. So They're first shredded and then melted, purified to make sure there's no impurities within that metal, and then cooled and solidified again. Lastly, these metals are distributed back to other plants to be processed and reused in other applications. And you can see in figure 2 a pile of scrap metal being sorted. This recycling of scrap metal has a big impact. It can manage waste management or minimize waste management in plants by reducing the cost of waste disposal. It has been seen that manufacturing can see energy savings of up to 90% by recycling all of the metal waste that they produce. And there's an opportunity for additional revenue for companies that decide to sell their scrap metal and make a profit. The last process I'll be going through is construction material recycling. So these are materials that are produced from demolition, infrastructure projects, or just general construction. There's a wide variety of materials that are involved in construction, and they're listed here. We have wood, metals, asphalt, glass, and gypsum. So depending on the type of material, obviously it's going to go through a very different type of process. So for wood, they reused wood would go through remilling or be used as a fuel source. Metals undergo the process that was outlined in the previous slide. Asphalt can be remelted and then reused in just as brand new asphalt. Glass is kind of similar, it can be melted and reformed, and then gypsum, which is drywall material, can be recycled, reused as drywall or cement, or applied in agriculture. And you can see in this figure a picture of a construction site that has sorted their waste for processing later. So the benefits of construction recycling are reduced disposal costs. Construction waste is one of the largest contributors to overall waste in the country. So companies could see huge benefits by cutting down the amount that has to be sent to landfills. And they can also see an increase in profits. So I found a quote here that a recent study concluded that companies can make about $50 a ton for cardboard, $5 a ton for paper, $150 a ton for plastic materials, $250 a ton for HDPE plastics, and about $1,300 a ton for metal materials like aluminum. So there's a lot of profit to be gained by some of these materials listed here. Some case studies that show where lack of recycling can and lack of proper waste management can be detrimental are listed here. Starting in New Jersey, the Ford Motor Company dumped about over 30,000 tons of paint sludge into the surrounding land, which ended up poisoning groundwater. So because of that improper waste management, the local community was very negatively affected. There was an incident in Oklahoma where runoff from a mining industry polluted local water, again, with heavy metals and lead. In North Carolina, the coal industry contaminated the surrounding land with chromium-6. In Montana, Anaconda Aluminum Company produced manufacturing waste that polluted the surrounding area with lead and chromium. Louisiana saw a company pollute marshlands with benzene and other chemicals. And in New York, a dump company leaked some organic chemicals into groundwater, again negatively impacting the surrounding community. So these are all examples of incidences where companies weren't as conscientious as they could have been about their waste management and ended up causing some very serious effects to happen in the communities around them. So some of the overall benefits for industrial recycling as a whole would be lower costs, which I highlighted before. By recycling, companies can reduce the amount they have to pay to send their materials to landfills, and they can repurpose a lot of materials to cut down on raw material costs. So financially, there can be a big gain by undergoing industrial recycling. There can also be energy savings for the country by these processes reduce greenhouse gas emissions, so that's better for climate change and the environment. Another benefit is companies can improve their reputation, as a lot of people are trying to be more aware of products that they're using and considering choosing companies that are friendly towards the environment. The industrial recycling would improve their reputation with these customers and potentially lead to higher profits. Another benefit is the creation of jobs. Industrial recycling requires a lot of operators to oversee these processes, so by increasing the amount of recycling, there could be more jobs in this sector. Companies could see increased efficiency by reducing waste and really getting the most organization out of their waste management. 6, they could observe compliance, which would be in regards to the EPA and regulations with the government. And then lastly, they could obtain green building certifications if they comply with the standards for recycling. In conclusion, the US is one of the top producers of industrial waste in the world. So through these processes that I outlined before, a focus on those materials could really make a vast improvement in the world as a whole. The country could benefit from increased levels of recycling with scrap metals and oils, other chemicals, and construction materials, and really benefit the people living in communities where industrial progress is being made. A recommendation I have for further improvement in this area would be spreading awareness and promoting benefits directly to companies involved in industrial production so that they can become more aware about the benefits of industrial recycling and increase their efforts within their own companies. Therefore, if we see increased recycling in each of these companies, the country as a whole will move in a positive direction and hopefully reduce impact on the environment and surrounding communities. Here are my references that I used. They were cited within the slides, and here they are in more detail. And that is the conclusion of my presentation. If you have any questions, I'd be happy to answer them, and thank you for listening.
In 2015, 195 countries came together to sign the Paris Climate Agreement and agreed to limit global warming to 2 degrees Celsius. A big contributor to global warming is carbon emissions, and a big contributor to carbon emissions is the petroleum industry. Now, companies in this industry have made changes and adjustments to try to be more greener and reduce carbon emissions, but increased renewable energy consumption is jeopardizing the global power held by petroleum companies. Renewable energy has made significant advancements in technology, making a major impact in consumer energy consumptions and a major impact in petroleum industries. So today we're going to go over the history of the petroleum industry and what petroleum is, and the different uses that petroleum has, as well as how the industry is affected by renewable resources and renewable energy. So what is petroleum? Initially, for me, I did not know what petroleum was. All I knew was little petroleum jellies, the Vaseline that you buy at Walmart. But that is not what petroleum is. It is not clear. Instead, it is this black, thick oil liquid that's from the earth. It's also known as crude oil. Crude oil and petroleum are literally the same thing. yeah, so it's from the earth, and the petroleum industry is the process of extracting that petroleum from the earth, refining it so that it can be used to be turned into a multitude of different products, and transporting the petroleum to places all around the earth. Now, oil attributes to, or this crude oil, petroleum, attributes to 80% of the Earth's energy, or energy consumed on Earth as of now. And while we do rely heavily on petroleum, and it does fuel a multitude of, or most other industries, renewable energy resources have been coming up and being more relied on, as well as technology has created advancements so that we can use renewable energy more. So, a little bit about the history of petroleum. Initially, in the early 1800s, we relied on coal for our fuel, especially in factories, with one of the first industrial revolutions. In the 1900s, World War I came up, which created a supply and demand for oil, for this fossil fuel, to create or to supply their ships, their planes, and factories to create products. And in the 1960s, the USA becomes the #1 producer of oil. Now, in recent years, we now use 100 million barrels of oil a day, roughly. Barrels is a unit of measurement for oil. And also today, companies and countries have come together to create regulations and policies and limitations on what can be released in the air, carbon emissions. We are trying to decrease that, as well as more effort has been put into relying on renewable resources, or just changing up the processes that attribute to a high amount of carbon emissions. Here is a diagram of where our energy, or the sources of energy from US last year, 2020. You can see that petroleum was the main one at 35%, natural gas came in second, and renewable energy is at 12% as of 2020. And you can see the different types of renewable energies. Solar and wind are most popular, or most familiar, I would say, but then there's also hydroelectric and biomass, which comes from the decomposition of organic material. An example of this is, or anything from manure to rotting onions can attribute to biomass. And here, not just 2020, but all the way back to 1950, you can see how renewable energy has increased in the U.S. So Iceland and Denmark are taking the lead for the countries who produce not the most renewable power, but renewable power per person, so per population. Manufacturing processes of varied petroleum products. So petroleum makes a multitude of products, which we will see, and so what happens is this petroleum is sucked up from the earth, it is refined and turned into a product that we can use. It is separated into the different products. Yeah. So, to go into detail, we have this wonderful, lovely flowchart that I may have made myself. We have, so petroleum is taken up from the earth. Again, it's this black, thick liquid. It's a mixture of hydrocarbons of different sizes, which is important, which we'll get to. So this petroleum is sucked up from the earth, and initially the liquid from the earth is about 90% water to 10% oil. and it also has a bunch of gases in it. And these gases are hydrogen sulfide, which gets turned into sulfur, which is then sold to farms to fertilize the soil, and then carbon dioxide and natural gases. Most of the original system process was that that CO2 was emitted into the air, so we don't need it, so we can just put it in the air, which is not good. But and natural gases were used to fuel the steam generators. Now, what the steam generators do is they produce steam, and that steam is sent down the wells and heat the petroleum, the raw liquid that is in the earth, to help extraction be more smoother because it's heated up, and so it's more liquidy. And the crude oil, water, and oil is separated, where most people are common how oil separates from water. Oil is at the top and then water is at the bottom. It's just like that process. Some chemicals are added to encourage that process to go a little faster. The water is sent to the steam generator. The oil goes through a multitude of processes to be refined. So then we have the oil distillation process. So here we take the refined crude oil and we heat it up. And remember, I mentioned that, so this crude oil is a mixture of hydrocarbons, and these hydrocarbons have different sizes. The largest molecules of these hydrocarbons have a high molecular force, which gives this collection of molecules a property of a high boiling point. And that high boiling point turns into heavy fuels, and versus smaller molecules, which have a lower intermolecular force, and they have a lower boiling point, so they get turned into vapor much more easily. So this refined oil is heated in this furnace until everything becomes a vapor, and then it is sent into this distillation refinery column, where once it leaves the furnace, the liquid the vapor cools, and just at 450 degrees, the large molecules with a high intermolecular force become liquid because its boiling point is so high. So that's how we get the heavy oil. And as the vapor increases due to the size of the molecules, they become liquid at different temperatures and become different products. Some examples of these products you can see, but we got lighter fluid is the lightest gas for cars, plastics, textiles, pharmaceuticals, and cosmetics, aviation fluid, diesel oil, heavy fuel, and asphalt, heavy fuel for ships and asphalt. Now, conversion into renewable energy. Because of the Paris Climate Conference, there's been a heavy encouragement to rely on renewable energy resources and to increase that technology. So some of the increased technology includes like floating wind turbines, and a major reason why renewable resources aren't like readily able to use is because the energy they produce, it's hard to store it. And with solar energy and wind energy, the sun's not always shining, the wind's not always blowing. So we need to find a way to hold the energy and be able to use it at a later time. So technology is increasing so that we can store that energy. There is a town in Norway that relies completely on renewable resources to supply the town. It includes wind turbines, solar panels, and biomass energy, which comes from a large amount of the manure from a lot of farms in the town. And lastly, so the petroleum plants, the oil plants, they have made changes to be more cleaner. One example of this is that rather than releasing CO2 into the air, which is not good, they are now releasing it into the earth. Thousands of meters, or 1 million tons per year, are released under the earth, under the sea. A case study is the E.ON company. It is a German utilities company. Originally, they supplied many thousands and thousands, millions of homes with their utilities. And between 2008 to 2016, they had a decrease of a third of their income, and this was due to renewable energy resources. So the company had to take a step back and look at their goals, and they decided to invest in renewable energy sources, as well as look towards being able to manage these renewable resources. So such as recognizing or just determining, having a plan for where renewable energy will go so that it can be stored or reused, or different places, different households can use this energy. So in conclusion, the petroleum industry has a significant power on the earth and economies today. But there are downsides to that, and the main downside is its physical effect on the earth. So we as a population of the earth can work together to create different technologies that can help us rely on renewable resources and less on these fossil fuels. And yes, I did not plan a conclusion, but I learned a lot from this experience, and I hope you did too. Thank you for listening. Goodbye.